Okay, so we have this class called employee.java, and within this class employee we have two strings, so name and email, and we have two ints, age and that's a typo. Oops. And so so we have name, email, and age, and we have our constructor. So inside our constructor, it's our default constructor. We have name is equal to Jim Kirk, email is equal to jim@kirk.com, age is 30. So we're initializing with some default values. We have another constructor right below it. So we will pass in a name, an email, and an age. And we'll call a method called setEmployee, which is further down here, which just basically sets name, email, and age over here. Now I'm using this on purpose, and you'll see why in a moment. We're going to assume that we've already created the getters and setters already. So we're going to assume we have already created the getters and setters. They're right here where this comment is. So we have set and we get, set and get, set and get for name, email, and age. Now what we're going to do here in the header file is we're going to start by breaking this object into two pieces. So in Objective-C, just like in C, we break things into two separate files. So we're going to have a separate file that will define all of the information we have inside our class. So we're going to have name, email, and age be defined in our header file up here. Right? And then what we do is in the second file, in the source file, which is a .m file extension, this is going to have our definitions for the actual code. So any methods we define in the header file, we're going to actually implement them here. So this is our implementation file. So we'll start off with our header file. We might call it employee.h. So just like in Java, we want to match the file names to the class name. So we'll call it employee.h. And in the source file, we'll call this employee.m. Okay? And so what we're going to do now is start by defining this object here. What I like to do when defining objects is I like to start defining it by defining the variables and then move into the source file. So jump to the M file and define the methods. And then in the end, take the method definitions and move them over to the header file to simplify coding. So what I'll do is I'll start off with employee.h. And what we're going to do here is we're going to define our class. So in Java, we would say public class employee. We're not going to write public class employee here. We're going to use a new term that is at interface. At interface is basically saying I am here about to define my class, but this portion of the class is the definitions portion. Kind of like interfaces in Java, where you defined a peek into the object itself by defining those method definitions. But here we're going to define our class, what it looks like, and what the structure is behind it. So we're saying at interface, it's called employee. Now, in Java, this would have been sufficient. We would have said public class employee and done. But in Objective-C, we have to go this step further and actually say what its parent class is. Now, in Java, every parent class is object. So we defined like public class employee, it's implied that it extends object. Here, we actually physically have to say it. So we're going to use the colon. So the colon represents extends. And then we're going to say NS object. So now this says we have this object called employee. It extends NS object. So what you took for granted in Java, you now have to physically spell out in Objective-C. Once we have that, we can start defining our variables. And we have to define our variables twice in this language. First, we define what our variables are. So we had name, email, and age. So we're going to say NS string name, NS string email, and NS integer. You can also use int, but I'm going to use integer here. Age. So we have name, email, and age. So this is basically saying here's our 3 variables that we're going to define inside our class. Now the next step is to define how what the memory characteristics are. And so we're going to go into the end of this and use this property declaration. So we're going to say at property, and we'll say non-atomic, and I'll talk about what this is in a second, and strong ns string name. We'll do the same for email. So at property, non-atomic, strong ns string email, and at property ns integer age. Okay. So what we're doing here with these 3 lines of code is that we are defining name, email, and age again, but what we're doing now is setting its memory characteristics. So like I said before, this language, we have to actually tell it how memory is handled in this language. And because of that, we're using 2 special keywords, which will go into deeper detail in the coming weeks. But non-atomic, if you recall operating systems, you have objects that could be shared between threads. And so by saying non-atomic, we are saying, yes, this is allowed to be shared between threads. If it was atomic, it'd be exclusive to one thread. Strong is the memory characteristic. We'll get into what strong means in the coming weeks. It basically says we want to hold on to this piece of memory as long as we can. That's what it's saying. With the basic types like integer or doubles or whatnot, you don't define any memory characteristics. You simply just say property and its integer age. Now, these are shortcuts for defining the get and the set. So we've actually, in essence, partially defined our getters and setters with these 3 lines of code. That's the main purpose of using property here. Whereas in Java, we would have had to have physically defined get and set, get and set, get and set over and over and over again. Here, we're defining get and set with these 3 lines of code. Now, this is only half the battle of defining get and set, but the other half of the battle is just as easy. In fact, easier than these 3 lines of code. And I'll talk about that in a moment. But what I want to do is I want to close off this file with the end, at end. So this essentially is saying that we are ending off the header file. Yeah, go ahead.
How do you determine if it's public or private?
Good question. So if it exists in this header file, it's public. If it was defined here in this M file, it's considered private. Once I define it here, and once I bring it over to here, then it becomes public. So it's assumed private until I bring it over here to the header file. Because what happens is that somebody's going to import this header file and start using whatever's defined here to run what they need to run in their object. But if it's not here, it's considered private and it doesn't exist to the other guy. So that's how we define public and private, by the status of the header file. Yeah. So that was the header file. Now what we do here is we jump over to the M file, or the source file. And when we want to start using this header file, we have to start by importing the header file. So we're going to say #import employee.h. And this is a line of code that any object that wants to use that header file will actually run this line of code in their file as well. So we're going to say import and the header file name for that object. So you were accustomed to import Java util scanner, right? Here is a similar idea, but we're importing a particular file. We're just saying bring this header file into our implementation, into our object, and we're going to start using whatever's defined in the header file. So now, like I said, we've partially defined the getters and setters for name, email, and age. We're going to finish off that definition here. But before that, we have to actually say that we are going to start defining a class. So we said public class employee, and up here in the header file, we start with add interface to say, hey, this is our class, but this is our definitions side of the class that belongs in the header file. Now we're going to say this is our implementation side of the class. So we're going to say at implementation employee. Don't need to say extends NS object, it's already implied in the header file. But now this is saying, hey, we're beginning our definition for the class here. Okay? So we have add interface, which says we're defining our class. We have add implementation, which says we are now going to finish off defining our class by actually physically going in and writing the code we need to write and all the methods we need to write. So we're going to finish off the getters and setters definition by using at synthesize for name, email, and age. So that's it. That's our getters and setters. Between at property and at synthesize, we have now defined our getters and setters. So no longer do we have to define those methods together. Yep, go ahead. So at synthesize is basically taking, I'm going to write out what I'm going to write out right now, and you'll see that at synthesize reduces that code down to this one line of code. So instead of this, for let's say for name, I would have had to have written the method for get name. So I might have said return type is NS string, get name, and actually written out return name. And I would have had to have written out the setter for it. I would have had to have said void set name ns string n, and then just say name is equal to n. So essentially, this got reduced down to this. So what happens is the compiler will actually take this line of code and turn it into this, but you will never see that. You'll never need to see that because it's done automatically. So whereas in Java, you had to write this out by hand. Here in Objective-C, you don't. It's done for you. And you would have done the same thing for email and age as well. Okay. So essentially what we do is we first say, go ahead and implement our variables. Okay. Now we saw a constructor there. We saw actually two constructors in this source file for Java. We saw public employee. We set name is equal to Jim Kirk. We set email equal to jim@kirk.com and age is equal to 30. And for me, you'll notice that no class is complete without a Star Trek reference. So we've started off by defining our object as Jim Kirk. Now we have to define the constructor here in Objective-C. And the way we do it is by defining a method called init. So like I said earlier, if I'm going to define a constructor, I have to define it like this. I'm going to say ID init. And so now I can go ahead and define the constructor. What happens first, though, is that you call the parent class's constructor first. Our parent class is NSObject, so we have to call the constructor for NSObject. And we do that by saying self is equal to super init. Now you're probably wondering what self is. In Java, we had the word this. We had the word this. In Objective-C, we have the word self. The reason why I put this in this case over here, because we didn't need to, we could have just written set employee, it would have been good enough, is because in Objective-C, there is no way of getting out of not using the word self. You have to use the word self to do things. So if I want to call a method from within my class, and you'll see that in a moment, I have to use the word self to say self and then the method name. And we'll see that used in a moment. But to start off with, I have to call the parent object's constructor. And so assuming that self does not equal nil, meaning it actually worked. We could actually call the parent constructor. Then we can go ahead and save our information. So we'll say like self set name at Jim Kirk. We'll say his email is self set email. And we'll say jim@kirk.com. And we'll say his age. So self set age. We'll set it to 30. And then the only thing left is because this method has a return type ID, we have to return something. So what we tend to do in constructors is we tend to return self, or return this. So we return ourselves. Because what happens is that this constructor is called when we instantiate an object. And what we're doing at that point is we are basically formatting our object, we're allocating memory, and we're basically sending it back to the caller. So we're sending back our object back to whoever calls this. So in Java, we would have said circle C is equal to new circle, while C is expecting to receive an object back that it can start using. So that's why in this constructor, we're returning ourself back so that that caller can start using the object. So that's why I return self. Now, we would do the exact same thing for the other constructors. We have public employee on the Java side. Well, we'll create a constructor right below it. So we created ID init. All we're going to do is right below it, we'll create another constructor. We'll say ID, and we'll say init again. So overloading is allowed, right? We could say init with data. We could also call it that as well. So I could even call this like init with data. That'd be perfectly fine as well. But as long as it has the word init and it has a return type ID, it is then treated as a constructor. We're going to say init. I'm going to pass in name of type ns string. I'm just going to call it n. And now I have to come up with labels for email and age. So just like I said earlier, you're going to pass in email and age here. So I'm going to call up a label. Let's say the email is ns string and then star e and then sorry, it's outside. And then the age ns integer a. And so now I have n, e, and a as arguments that I'm passing in. The labels are the email and the age, okay, for the other two variables. So I'm going to go through the same motions again. I'm going to say self is equal to super init. And then I'll say if self does not equal nil, meaning it actually was able to call its parent constructor. Now here, we have that line of code, set employee. Well, I'm going to create that method below and then finish this off after. So the last step would be to return self, and we'll leave what's inside the if statement for our third method, which is set employee. So I'm going to create that method down here. So I'm going to say void set employee and pass in ns string n and have the email as ns string e and the age as ns integer a. Right? And then I'll just say self set name is equal to n self set email e self set age a. Right, and that's it. Then I can call this method up here and say self set employee for n the email as e the age a. And the only thing left now is to end off this file by using the end keyword at the end. At end. And so essentially, this is a walkthrough of taking a Java object, converting it into two pieces.